Hi everyone, this is Merishna, a graduate student in data science at the University of New Haven, and today I'm here to present my final project for natural language processing with my team members Sujan and Rishrant. And the topic of our project is Nepali offensive language detection and sentiment analysis. Now let's begin with a quick overview of the project objectives. Our objective is to build an offensive language detection model for Nepali text, which is a low-resource language, and also contribute to a safer online environment in the Nepali-speaking community. Let's look at the linguistic differences between Nepali and English. As you can see, Yes Prastuti Ma Swagat Sa is the text that is written here in Nepali, which translates to Welcome to this presentation. As you can see, Nepali is an Indo-Aryan language which uses Devanagari script, and it is commonly spoken in Nepal, India and Bhutan, as opposed to English, which is a Germanic language which uses a Latin alphabet and it is spoken worldwide. Now let's review some of the state-of-the-art models that have used hate speech detection or offensive language detection. So as we can see, numerous studies have been done in English, particularly such as HateBird, which fine-tuned BERT for abusive language detection, as well as offensive language identification and categorization in 5 languages. One major inspiration for this project was also fine-tuning domain-specific language models, such as BioBird, Financial Bird, and Legal Bird, which have shown great performances. There are also some studies in Nepali which work on this aspect, such as offensive language detection using supervised machine learning and aspect-based abusive sentiment analysis using BiLSTM. And both of these researches have great results. So when we look at the challenges in cross-linguistic transfer of offensive language detection, we can see that many models which are trained in the resource language of English do not perform well in unseen tasks in the target language, which is Nepali. The problem is that they are not suitable because of the linguistic diversity, cultural differences, and morphological differences, as well as shortage of data resources. So our approach is to use a pre-trained model and then fine-tune it for our particular purpose, that is name entity recognition and sentiment analysis to detect the offensive languages in a sentence, offensive words in a sentence. So we have a large corpus, Wikipedia, book, or online sources which are used to train these pre-trained models. And we take this pre-trained BERT model and pass in our training data set for the downstream task, and we fine-tune it for the NER and sentiment classification, which gives us our fine-tuned BERT model, which can be used then for inference by giving any input and gives out our output for the particular fine-tuned task. So let's take a quick overview of the training dataset that we have used. So this is the dataset that we have taken from the aspect-based abusive sentiment detection paper, and it has the following categories for the aspects which are general, profanity, violence, and feedback. And we have only taken the 3 of them, which is general, which means positive criticism, derogatory remarks or insults, profanity and vulgarity, which is disrespectful and inappropriate words, and violence, which involves discrimination, abuse, and hate speech. We also pre-processed the Nepali text because it was very different from the English text. So we performed stemming for the text, which includes iterative separation of morphemes, stop words removal, and spelling correction. So this is an example which shows a text which means Raju ate lunch. Over here we are separating the morphemes Raju and Le and Kai and Ko, and the word at the end cha has been removed because it is a stop word. And we have also handled imbalanced classes by random undersampling, which means removing random samples from the majority class with or without replacement. So this was a dataset that we originally took, and this was the dataset statistics after data balancing, and also splitting it into train, validation, and test. So our first task is the offensive aspect detection, which is the name entity recognition task for 4033 sentences with multiple aspects. So this is an example, Tapaikuama dubera more hunta, which means you can go die in the well. So go die over here is profanity, and this second sentence means who thinks that this Punya Gautam is a drunkard. So the drunkard word is classified as a general negative word. Our second task is sentiment classification. So it is a sentiment analysis task, and we have these classification labels, which is general positive, negative, profanity, and violence. So these are some of the examples for general positive, negative, profanity, and violence. For evaluation, for the named entity recognition task, we used 5 different models: XLM Roberta Large, BERT-based multilingual cased, NepBERTA, DeBERTA-based Nepali, and DistilBERT-based Nepali. So the last 3 models were trained on Nepali text as opposed to the first 2, which were trained on multilingual data. Sentiment classification model as well. We used 2 models that were trained on the multilingual data and 3 models that were trained on Nepalese data. And the XLM Roberta Large performed the best for the named entity recognition task as opposed to the sentiment analysis task. The DistilBERT-based Nepali, which was trained on the Nepali data, performed the best with an accuracy of 72.24%. We then performed some optimization techniques on the best performing model for both NER and sentiment classification, and we used early stopping based on F1 score by validating it for every 100 steps with a patience of 2 and saving the best model, and we were able to improve our test metrics with an accuracy of 83.25% and 74.52%, and an F1 score of 60% and 72.3% for NER and sentiment classification task. Now let's take a look at the inference on best performing models. So this is the code that we have used for inference. Here you can see the models that we have fine-tuned on the pre-trained BERT models. So the first one is the sentiment analysis model, and the second one is the named entity recognition model. So if I run this, I also have a sentence over here, and here it shows that it is profanity, and indeed the translation of this sentence has this particular word that means slum dweller, and it is a profane word. And for the named entity offensive entity recognition as well, if we run this same code, we can see that it identifies the word slum dweller as profanity, the word adivakta, which means advocate, as miscellaneous, and this person's name Dinesh Tripathi as the person. And we can also try and see any comments from a YouTube video which is in Devanagari script. So if I put it here and run this, it predicts it as violence, which is correct. And if we also run it for name entity recognition, it identifies the words balatkari, which means a rapist, and there are also other violence words, and sajai hunu parsa is a feedback. So for future improvements, we plan to do an in-depth study on the misclassified data for particular model improvement. We could also handle some code switching, such as text that uses English words interchangeably in between, as well as we could implement Romanized Nepali text into account. So right now we are only using Devanagari script, but we could use Romanized Nepali text, which means that it is typed, the Nepali words are typed in English. Thank you. That is it for our presentation. And for any questions, you can email us at these email addresses. Thank you.